morning friends, I am back again with one more video lecture on the topic partial differentiation. Now we will discuss one of the important theorem of partial differentiation is that Euler's theorem on homogeneous function. Now Euler's theorem states that if f of xy is a homogeneous function of x and y of degree n, then x times del f by del x plus y times del f by del y is equal to n times f. Now here f be the given function f of xy. Now proof of the Euler's theorem. In Euler's theorem, this f of xy is a homogeneous function of x and y of degree n, and therefore by definition of homogeneous function, this f of xy is equal to x to the power n times f of y by x, or y to the power n times f of x by y. Now this denoted by 1. Now first we find the derivative of this f with respect to x, keeping y constant. The differentiating this one with respect to x, keeping y constant. Now derivative of f with respect to x, answer is del f by del x. This is equal to, now this x to the power n is a function of x, it is denoted by u. Similarly, this f of y by x is also a function of x, it is denoted by v. And therefore by applying the product rule of differentiation, this u as it is, derivative of v means x to the power n as it is, derivative of f of y by x, answer is f prime of y by x times derivative of y by x, answer is minus y upon x square, plus now v as it is, derivative of u means derivative of x to the power n, answer is n times x to the power n minus 1, and this v as it is means f of y by x as it is. Now multiplying this del f del x by x, so multiplying by x, so therefore x times del f del x, this minus sign, this x to the power n is as it is, this f prime of y by x as it is. Now x times y upon x square, the one is get cancelled, the answer is y by x plus n, and x times x to the power n minus 1, the by using the laws of indices, x times x to the power n minus 1, answer is x to the power n times this f of y by x. Now it is denoted by equation number 2. Now we calculate del f by del y means derivative of this f with respect to y, keeping x constant. The differentiating this one with respect to y, keeping x constant. Now derivative of f with respect to y, answer is del f by del y, and this is equal to this x to the power, x is constant, therefore x to the power n is constant, so this is as it is. Now derivative of f of y by x, the answer is f prime of y by x times derivative of y by x, the derivative of y, answer is 1, so therefore derivative of y by x, answer is 1 by x. Now multiplying this del f by del y by y, so multiplying by y times del f by del y is equal to x to the power n, this is as it is, times f prime of y by x, this is as it is, and y times 1 by x, answer is y by x. We denote it by number 3. Now adding equation 2 and 3, adding 2 and 3, we get now x times del f del x plus y times del f del y, and this is equal to minus x to the power n times f prime y by x times y by x plus x to the power n f prime of y by x times y by x. So this minus plus this get cancelled, here answer is 0, plus now last term be the n times x to the power n f of y by x. Now according to the equation x to the power n f of y by x. Answer is this f of xy or simply f. So therefore x times del f del x plus y times del f del y is equal to n times f. Hence proved. Hope all of you have understood this Euler's theorem on homogeneous function of two variables. In the upcoming lecture, we will solve some problems based on the Euler's theorem. Please subscribe the channel and let me know your comments and feedback. Thank you.